Unit 2 Chemistry, Chapter 13, Part 3. So looking at ionic substances and which ones dissolve and which ones don't. So not all ionic substances will dissolve, but all of them which have got these ions in also will. Okay, so it's got the nitrates, the ethanoate, any group 1 metal or ammonium ions in it, it will always dissolve. Chloride, bromide, iodide and sulfate normally dissolve, but they have some exceptions. Okay, so most things with chloride in them dissolve, but silver chloride or mercury chloride don't. Okay, so these exceptions here are the ones that do not dissolve. Similarly, we can say that most of these ones don't dissolve, but they do have some exceptions, and in this case the exceptions are the ones that do dissolve. So most carbonates don't dissolve, but sodium, potassium or lithium carbonate always would dissolve. Okay? Ways to remember it. Think about snacks, chips and Bix. Okay? So your snacks are your always soluble. Your sodium, your nitrate, your ammonium, your potassium. Chips are insoluble unless you pair them up with one of the snacks. So carbonate, hydroxide, phosphate and sulfide are always going to be insoluble unless you pair them up with one of the previous ones. And Bix, they're soluble unless you put them with silver, lead or mercury. So bromide, iodide, chloride and sulfate, soluble except in those circumstances. Now we can exploit this because sometimes we can react to things where the ions have dissolved and make a solid, which is insoluble. This is a process called precipitation reactions. Okay, so in silver nitrate, we've got silver ions and nitrate ions and they're perfectly happy separate. Sodium chloride, sodium and chloride ions are separate. But if you mix them together, the silver and the chloride ions are going to find each other and they're going to bond really strongly. And that's going to make an ionic lattice, and that's going to be a solid precipitate. Okay, so we can write this as saying that we have sodium chloride, aqueous, plus silver nitrate, which is aqueous. It's a double displacement reaction, so everyone swaps partners. Okay, so this cation goes with that anion to make silver chloride, which is now insoluble, and that becomes our solid. And this cation now goes with that anion to make sodium nitrate, which is still soluble, so has the aqueous one. We must have the states in these, because what's most important in precipitation reactions is what actually has precipitated out. Okay? Now because this is aqueous, that means that these are actually separate hydrated ions. Which means we can actually simplify the equation quite a lot. Okay, because all these things which are aqueous actually exist as their separate ions. So it's actually sodium ions and chloride ions and silver ions and nitrate ions, sorry that should have a negative charge, make sodium ions and nitrate ions and silver chloride. And many of you are probably going, hang on, that's not simpler. It's not. But the sodium ion is the same on the left and the right. It's the same charge, it's the same state. So it needs to get crossed out because it hasn't done anything, it's just watched. So we call it a spectator ion. Similarly, the nitrate, again, I apologise for the charge, but this is NO3 minus here and NO3 minus here, so it hasn't changed at all, so it gets crossed out. That's another spectator. So all that's actually happened is we took aqueous chloride ions and aqueous silver ions and we made silver chloride as a solid. Now that's simpler.